This is Time in the Calendar by Sethanne Howard of the Washington Academy of Sciences. So let's look at the history of time and what it means for the calendar. People were interested in this for a very, very long time. The earliest I could find records for is the Maltan standing stones in the island of Malta, and they were marking the passage of the moon on the standing stones 6,000 years ago. And the megalithic chamber tombs, Newgrange in Ireland is one, and it marks the winter solstice. And Mesopotamia, of course, was where a lot of work was done. And they had water clocks and huge libraries of tablets. Egypt, of course, gave us the solar calendar. There were three different epochs for Stonehenge, but the story I want to tell you is about China. China had cared about this important, and eclipses were important because eclipses were important for the kings and rulers and emperors. So around 2100 BCE, the emperor of China noticed a solar eclipse, and it was not predicted by the court astronomers. The court astronomers were High and Ho, and they failed to predict the eclipse because they were out partying and got drunk. And the emperor chopped off their heads. So it wasn't safe to be an astronomer in those days if you missed an eclipse. There they are, High and Ho, drinking. And then down at the bottom, you see the first date of the Mayan calendar is way back here, more than 5,000 years ago. And if you remember, in 2012, there were people who were claiming the world was going to come to an end because on December 21st, 2012, the Mayan calendar started over. So if you were a pessimist, you believed in that. But I'm an optimist, and I knew that 2012 was the 100th anniversary of the Oreo cookie. And you know that it looks very much like the Mayan calendar. Same kind of indentations. So that's the optimist view. That's the one we're going to take. 2012 is not the end of the world. We're still going on. And I'm going to talk about cycles. Cycles and time, cycles in the calendar, and our current calendar. Cycles are the important thing. I got sick of cycles when I took science because everything was in cycles. And it still is true. Everything is cycles. So let's look at cycles in time. There are three important cycles. The diurnal cycle, which is the daily cycle. And to do that, you track the position of the sun as it goes across the sky. Then there's the lunar cycle, which is the monthly cycle, which tracks the phases of the moon as they go through the month. And the seasonal cycle, which is the yearly cycle, which is summer, fall, winter, spring, going around the seasons, 4 seasons. So those are the three important time cycles: diurnal, daily, lunar, monthly, seasonal, yearly. So let's do them one by one. The diurnal cycle in time, and I don't know if you can see all of this because I see some people over here blocking the picture. Do you see them blocking the earth going around? No, you see the earth and the sun and the objects east of the sun and west of the sun? Oh, you can see that, okay. Remember that everything goes counterclockwise and you'll get it right. Diurnal is 1 solar day, 24 hours. A solar day is the time of one transit of the sun overhead to the next transit of the sun overhead. That's one complete rotation of the earth. We track the sun to mark each day, and the earth rotates west to east at 15 degrees per hour. and it's per hour. And that's why the longitude lines are 15 degrees or an hour apart, because 24 hours at 15 degrees per hour is 360 degrees. That's one full rotation around. That's why we have 24 longitude lines. And they're approximately an hour apart in time. I'm not going to talk about latitude and longitude. I just mentioned that. Now, what's important to know is the daily rotation of the Earth is our primary timekeeper. The Earth is in charge. All clocks are interpolating devices to measure the time between successive transits of the sun overhead. Now, people may argue and say that atomic clocks keep better time. They don't keep better time, they keep more precise time, but they still get out of sync with the Earth. And they have to be corrected to bring them up to what the Earth is doing. The Earth is what's in charge, not the clocks. So that's important to remember. Tracking the sun, here's a picture of 3,000 years ago, a base plate of a gnomon, a sundial in ancient Egypt, the base plate. And the stick that defines the gnomon would be in that little hole. And here is a gnomon with a triangular stick in it, modern day. And here's this is the shadow. And the shortest shadow defines the transit time overhead. When let me get my arrow over there. When this shadow gets to be the shortest, that's when the sun is directly overhead, and that's the middle of your day, noon. So you can build a sundial, but I ought to mention the biggest sundial I know of is in India, and it's the UNESCO World Heritage Site. Maybe some of you know about this. I've never seen it. I would love to be at this astronomical site where they built all these humongous instruments. And this is their sundial. And you see the tree in the back? That gives you a sense of how tall it is. And down here are the arches that you can walk under. So this is enormous. And they could keep time very precisely with a sundial this big, supersized gnomon. Have any of you been there? Jaipur? No? It has lots of astronomical buildings, pre-telescope. So if you want to build a sundial, you need to point your gnomon, your stick, in the northern hemisphere at the North Pole. That means you need to know your latitude. That's not hard. And when here's the sun, position 1, and there's its shadow. Position 2, its shadow would be right at noon, the shortest. And position 3 would be the shadow over here as the sun moves through the day. Now, we know the sun isn't really moving, but as the Earth rotates through the day. So how do you determine your latitude? And this, everybody, they knew this thousands of years ago. This is not new. The altitude of the Polaris, the pole star, is your latitude. All you had to do was measure the angle it was up from the horizon, and you knew your latitude. However you measured angles. I mean, it could be any kind of measurement, but as long as you were consistent, that was your latitude. You'd need, in the southern hemisphere, it's a little trickier because they don't have a pole star. But you can do this with the sun, and it's also trickier because the altitude of the sun is not your latitude. You have to do some mathematics. So it's easier if you do it with Polaris, the pole star. Okay, the lunar cycle and time. This is a picture from astronomy textbooks, and it's not one that's my favorite. I find it confusing, but nevertheless, it's all there is. The sun comes in here from the left. Here is new moon, right there, and everybody goes counterclockwise. and you won't get it wrong if you go counterclockwise. The Earth is rotating counterclockwise. The moon is orbiting the Earth counterclockwise. So we're going to cycle through the phases of the moon. That means we're going to go from new moon to new moon. New moon all the way around to new moon. And that's 29.531 days. That's a lunar month. So the lunar cycle was announced every month by the scientists or the astronomers of the tribe in the ancient world, and they were called by Greeks a synod. We still use the word today in the Catholic Church they're called a synod of bishops. Well, they're the ones who would announce each new moon. There's the Greek synodos. So they would announce each new moon. One cycle through the phases of the moon is called a synodic month. That's why, that's where synodic came from. If you've had a little bit of background in astronomy, you may have heard of synodic month, but it comes from the fact that the astronomers in the tribe were called a synod. 29.531 solar days is approximately one synodic month, approximately. We know it a little better than that. And it's not an exact number of days. That's important. It's the earliest timekeeper. People used the moon to track time, and that was their first kind of calendar, was a way to track new moon to new moon to new moon to new moon. But when you did that, you didn't add up to the seasons, because the seasons, summer, fall, winter, spring, didn't track with the lunar cycle at all. So the seasonal cycle cycled through summer, fall, winter, spring, counterclockwise again, and that's the tropical year. That's defined. There are several kinds of years, and the one that goes from summer, fall, winter, spring to summer, that's the tropical year. One full year. It's marked by the turning of the seasons. That's what the word means, tropical means, turning of the seasons, yearly revolution about the sun. And that's its length, 365.2421897 days. And those are all known, those are precise. Those are all significant digits. That's how well we know the tropical year, at least this year. It's different every year, but we know it to that many significant digits. The tropical year, therefore, is not an exact number of lunar months or an exact number of solar days, unfortunately. And each season is marked by a special day in the year. And you've heard of these, the solstice and the equinox. The summer solstice is the longest daylight hours. The winter solstice is the shortest daylight hours, and these are a picture. Show a picture of Stonehenge at sunrise and sunrise in the summer. And this year, I understand that they're going to live stream the summer solstice at Stonehenge across the world, so everybody will get a chance to see it. Equinox is sun up for 12 hours, sun down for 12 hours. In other words, equal nights, equinox. There's a spring equinox and a fall equinox. So we've got 4 special days, 2 solstices and 2 equinoxes. The solstice, the word means sol, sun, standing still between the stones. Here are the stones, stis. Interstitial is a cognate with solstice. The rising sun would rise between the stones that mark the calendar. These were the stones around the circle, like Stonehenge. And the sun appeared to rise at the same place on the horizon for a long time. That is the solstice, sun standing still between the stones. There are 2 per year, summer and winter. they mark the longest day of the year and the shortest day of the year, which I said. This coming summer solstice is at 5:43 p.m., June 20th, Saturday, Eastern Daylight Time. So that's a point in space, and that's the time of the summer solstice this year. And so that's when you will see it being live streamed from Stonehenge. The equinox, on the other hand, means equal day and night. It occurs when the length of daylight hours equals the length of nighttime hours. And they're 2 per year, just like the solstices. We've got spring and fall. And the spring equinox was Friday, March 20th, 3:49 universal time in Greenwich, England. And that meant in the United States, it was Thursday, March 19, 10:49 Eastern time. That was the spring equinox. The fall equinox will occur Tuesday, September 22nd, 9:30 Eastern Daylight Time. You have to calculate these guys in advance. That's part of the tricky part. That's why you need astronomers. They need to calculate all this stuff in advance, at least 2 to 3 years in advance. But most people don't realize there are cross-quarter days. The 2 solstices and equinoxes are 4, and they divide the year into quarters. But halfway between a solstice and an equinox is a cross-quarter day that marks 1/8 of a year. And these cross-quarter days in the Western world had ancient religious significance. May 1st was May Day, dancing around the maypole. August 1st was Lammas Day, which is the earliest fall festival of fruits and vegetables. November 1st was All Souls Day, with Halloween the night before. And February 2nd, my particular favorite, was Groundhog's Day. Those are cross-quarter days, and that's what they're called. So if people ask you what's important about May 1st, you can tell it's a cross-quarter day. It has astronomical significance. It marks the year into an 8th. So you have 8 holidays you can have per year that are just free because the astronomy gives them to you. Now, what type of calendars do we have? Well, calendar comes from Latin, the word calare, to proclaim, which means they would proclaim the calends of the month, which is the beginning of the month, the new moon. The new moon that would begin the month was called the Roman calend. So that's where the word calendar comes from. The lunar year is composed of 12 synodic months. It's about 354 days. The solar year has 4 seasons, 365 days. They're not the same. And then there's the lunisolar year. This is when the people realized they weren't the same, and they tried to create a solar year using lunar months. This was tricky. You couldn't do this just easily. So there are people who still use the lunisolar year. That's fine. We figured out how to do it now, but early on, it took a lot of work to create a solar year using lunar months. Just to get technical for a second, the synodic month is 29.53095. I can't see what's beyond the 9. And the tropical year, that's its precision, 365.2421897 days. That's the only technical bit I'll throw at you, all the significant digits we know. Now, everybody, every country, every city had its own favorite New Year's Day. It could be the birthday of the ruler. It could be the start of the founding of the city of Rome. That's one of them. They were different days of the months, 1 January, 1 March. 15 March was the Ides of March. The spring equinox Christmas for the Christians, and it could be any kind of holiday, astronomical event, birthday, or more importantly, the day the taxes were due. That was important. But unfortunately, it's an unlucky accident that the lunar year is close to the tropical year, because 12 lunar months are very close to the length of the tropical year. Close, but not exact. 354 and 365 days about. That's an unlucky accident because it meant people thought, gee, they're close enough. They ought to come out even. Let's make them come out even. But the lunar year keeps slipping off the cycle of the seasons. So the lunar year does not track with the seasons. After so many lunar years, you won't get the same season occurring at the same time of the lunar year. It just keeps slipping. But they were close enough that people tried hard to make a tropical year based on lunar months. Pity. I mean, if they weren't so close, people wouldn't have tried this. But because they were so close, they tried to make a lunisolar year. And in the China and India, by the way, and a few others, still use a lunisolar calendar for holidays. So they're still in use. And in 5th century BCE, the Greek meton set down the rules for inserting extra months. And you start with a year that begins on a new moon. That's when you start your count, your cycle. It will take 19 years before this occurs again, that the beginning of the year starts on a new moon. That's called the metonic cycle, 19 years. So you take those 19 years and insert in a preset pattern extra months to make the days come out to 365 in a year. And every 19 years, you repeat that pattern. So the golden number runs from 1 to 9. They thought it was so important that they would engrave the number of where you are in the metonic cycle in gold on the pillars on the Acropolis in Athens. And it's called the golden number. And we still use the golden number today to calculate Easter. And this provides great job security because astronomers were the ones who you had to have to get to the calendar. And it was the main duty of ancient astronomers. So calendar was important for agriculture, obviously, for when you planted crops. And as I said before, taxes. Hammurabi in Babylon said to the astronomers, okay, guys, get with the program because the year is out of place. I want my taxes paid, and you have screwed up the calendar, or the calendar has gotten screwed up. So please pay taxes on the 25th of Ulu the 2nd instead of 25th of Tazritu. And I need my taxes. And that's how important it was. That's why taxes were important. And taxes involved sheep and goats and cattle. And at 1 year in Babylon, 36,000 sheep were given to the temple. So this wasn't a minor few trading a few sheep. Now the Islamic world uses a purely lunar calendar. And each synodic month begins with a visual sighting of the new crescent moon. A lunar year is 12 synodic months, and that means the Islamic year, the lunar year, systematically shifts with respect to the tropical year, the solar year. So after 3 days, the shift reaches 33 days or more than one lunar month. That means Ramadan. That's why Ramadan is a different time in the solar year each year. It's because they're going by a lunar calendar, and we're going by a tropical year. The solar calendar started in Egypt. When the year began when the Nile rose, flooding of the Nile, each month had 30 days, each year had 360 days with 5 extra holidays at the end. I like this year because you worked hard for 360 days and then you partied for 5. I think that's a wonderful kind of calendar, and it worked well for the Egyptians. Then the Romans entered the picture. This is a calendar, this is a calendar stone used by the Romans, the picture. They used a flaky lunisolar calendar. They started their New Year's Day in March. They had 10 months, and they would randomly shuffle the months around, and basically it was a mess. The Romans couldn't get it together. And it was 80 days out of sync with the seasons when Julius Caesar entered the picture and borrowed an astronomer from Cleopatra and said, we're going to create a solar calendar for Rome. Sethanne was the name of the astronomer that he borrowed. This is the Roman reform, the Julian calendar. He made it a solar calendar. He moved New Year's Day to January the 1st from March the 1st. Then he would scatter 5 holidays throughout the year, and he made 7 31-day months, 4 30-day months, and 1 28-day month. So to make it come out to 365. Now, to make it come out to 365 and a quarter, he would add an extra day 6 every 4 years on day 6 before the March calend. Calend was the new moon, the beginning of March. So this would be the 6th day before then, the 6th day before the March calend. And that's why you would get double 6s. So bisextile year is the official name for a leap year. Double sixes day. That's where it came from, because they would add an extra day 6 before the March calend. So to clean it all up, he said, we're going to do this in 46, and we're going to make a year of 445 days to get everybody up to speed and start out clean with the Julian calendar. But then we lost Julius Caesar. He was killed, and Caesar Augustus came in, and they messed it up. They messed up. They didn't add in the extra day 6s. They added them in the wrong place. They changed the month around, and they essentially lost touch with the Julian calendar. So Caesar Augustus said, I've had it. In 8 BCE, I'm going to say nobody does anything, and we're starting over again until at 8 CE. So he named the 6th month to August, and then the Julian calendar operated from 8 CE to 1582 CE. And in 325, the Julian calendar was established as the calendar for the Roman Catholic Church. Orthodox Christians, though, still follow the Julian calendar. That's also the ones in the eastern part of the world. Orthodox Christians, Greek Orthodox, Russian Orthodox, they still follow the Julian calendar. That's why their Christmas and their Easter are different, sometimes different than the ones in the calendar we use today. So Easter was a problem. When does Easter occur? Here are the rules. It's the full moon preceding Easter was not to precede the vernal equinox. That's rule 1. Rule 2, Easter is the Sunday following the paschal full moon on a lunar calendar. Rule 3, the paschal or Easter month is the first one in the year to have its 14th day, which is the formal full moon, on or after 21 March. Easter is the Sunday after its 14th day. So all 3 of those rules have to be satisfied to pick a date for Easter. That's complicated. It's not as simple as just what we say today when Easter occurs. And you'll notice that sometimes they get Easter on the wrong day, the general populace. The canonical Easter tables were devised by the end of the 3rd century, and they had tables to calculate Easter, and they used the lunar calendar, the lunisolar calendar, the solar calendar, the golden number. All of those were folded into the Easter tables. And it required computing the time of many future full moons and future equinoxes, and every country did it differently. So you had a bunch of different Easters. Then Dennis the Little came along, and in 530 he constructed his table, which was very clean and neat, and he called them Anno Domini, and that's where AD method came. He called them the AD, Anno Domini, in the year of our Lord Jesus Christ, and he called them AD, and the AD method caught on. It became popular, and that's why we have AD today. We don't, most, the Christians say AD and C, but historians use Common Era CE and before the Common Era BCE. But however you do it, computing the days of Easter remains a complicated mixture of several calendars. It's not trivial. And in US, the official date for Easter is given by the US Nautical Almanac Office. That's where the date comes from. They're the ones who define the calendar for the government. So why do we get rid of the Julian calendar? Well, let's go on a trip. We're going to leave Venice on March 1st, 1245, travel to Florence, which had a different New Year's Day, and arrive in 1244. Before you left Venice, you're going to arrive in Florence, then on to Pisa by 1246, on to Provence in 1245, and finally get to France by April 16th, 1244. In other words, you get to France before you left March, and you're carrying a commercial contract you want signed. This is going to make it tricky. How much money do you owe for the amount of time that's elapsed? It's going to be really difficult to calculate that. So it caused a lot of commercial angst, the Julian calendar. In addition, by the 16th century, the Julian calendar had slipped the spring equinox from March 21st to March 11. So Easter was now out of sync. So Pope Gregory, Roman Catholic Pope, hired some astronomers, dropped the 10 days between October 4th and October 15th, and October 5th became October 15th. The days of the week did not change. So this happened in 1582 in October. So the leap year rule, as all of you should probably know, if it's divisible by 4, it's a leap year, except for years that are exactly divisible by 100. Those are not leap years, unless the years that are exactly divisible by 100 are also exactly divisible by 400. Those are still leap years. That's a little extra PS on the leap year rule. The Gregorian calendar is an average 365.2425 days in length. That makes it agree to within half a minute of the tropical year. That's a good thing, because it's going to take 3,300 years before the Gregorian calendar has gone as much as one day out of step with the seasons. Now, there are many people around the world who keep coming up with new calendars and say, we want to make it better. We have this idea for a calendar or that idea for a calendar. But so far, nobody's come up with one that's as useful as the Gregorian calendar. And actually, the whole thing was to clear up the date for Easter. Not really to make the commercial people happy. So it was done by the Roman Catholic Pope. So the Protestant countries did not want to adopt a Roman Catholic calendar. So the days kept slipping, and the Protestant Easter fell further out of sync. The Gregorian calendar was going along, but the Protestant calendar was still the Julian calendar. Eventually, though, the Protestant countries said, okay, we cave. We're going to adopt the Gregorian calendar. And in September 1752, September the 1st and 2nd, and then it became the next day, Thursday, became the 14th. It's the shortest September in history. This one, because it's missing 12 days. And because it was short, the landlords still wanted all their rents for the whole month. And so there were riots in Boston by the rentees who said, we don't want to pay rent for the whole month because we're only paying rent for these many days. So there were riots in Boston over this change. It was quite a source of angst for the people. So we have 3 calendars now. A solar calendar, that's the Gregorian calendar. It depends on Earth's orbit. It's used worldwide by international treaty. And interestingly, there's no year 0. A lunar calendar follows the lunar cycle without regard for the tropical year. This depends only on the lunar phase cycle and has 354 days per year. And there are countries that use this. I'll show you who they are in a minute. And a lunisolar calendar combines a lunar with a solar calendar. Every few years, a whole month is intercalated or interspersed or stuck into the 19-year cycle to bring the calendar back into phase with the tropical year using the golden number. The countries in green use the Gregorian calendar for everything. The countries in orange use the Gregorian calendar for international treaty and alongside their own local calendars. And the countries in red do not use the Gregorian calendar. And the countries in blue use a modified version of the Gregorian calendar. Japan is a country in blue. Right there. So that's how it's spread around the world. And these use the Gregorian calendar for international trade, but have local calendars for their own religious holidays. Now, what happened to Washington's birthday? I know you were just dying to know. George Washington was born, according to the rules, on February 22nd, 1732 on the Gregorian calendar. But at that time, the British Empire was, and that's the colonies, was still on the Julian calendar at that time. The British Civil Year began on 25 March, not 1 January. So in 1752, which is after George Washington was born, the British Empire switched to the Gregorian calendar. That meant that Americans born prior to 1752 typically have their birthdays given as if they would have been under the Gregorian calendar. But his actual birthday is February 11th, 1731 on the Julian calendar. So you can have fun with birthdays if you know what the different calendars are. And we'll end with astronomers are not responsible for this. We do not do daylight savings time and standard time. It's Congress that does that, not the astronomers. And so here they are hating to change to daylight savings time like the rest of us. And so are there any questions? We'll leave that up there. And does anybody have any questions? Unmute your microphone and
this is Joe. No, I thought it was wonderful talk. I had no idea about some of those things you talked about there. It was great.
thanks.
Excellent, very educational, Sethanne. It was great.
Yes, I enjoyed it. Sethanne, I have a question that I've had it for many years because I've heard contradictory stories about the time of birth for Jesus Christ. Do you celebrate that in December 25? And
Yeah.
I've heard the stories in the Islamic stories that when Jesus Christ was born, they were serving Mary with dates from palm trees, and that is during summertime. Have you heard anything about that? Do you know anything about
Actually, the current biblical scholars think he was born in the spring.
Really?
Yeah.
Oh,
December 25th was picked arbitrarily because it fell on the same time as the Roman Saturnalia.
oh,
And they
okay.
wanted to steal away the Romans from celebrating the Saturnalia and move to Christianity.
Yes.
And they put it on December 25th because that was the Saturnalia, their
That's
big
right.
celebration in Rome.
Yes.
That makes
Yeah.
So the stories could be close, I guess, because if they were serving date, it would be toward the midsummer, maybe, I don't know, maybe close, maybe early summer.
Early summer, yeah, they don't know exactly when, of course.
Yeah. Yeah,
But
okay, all
they
right.
said it was lambing season.
How did they find out about that? You said they recently discovered that?
Oh, no, it's been known for a good 50 years.
Oh, really? Okay, all right.
Yeah. I read about it 50 years ago. And
you're not much older than 50. How could you read about it?
I read about it in books. Books older than me. Then it was lambing time, which would make late spring.
Okay, all right.
They think it was the time of birth of lambs
Okay, all right.
because the shepherds were in the fields lambing.
Okay.
Now I have a question. So why the new year is January 1st? Why is not December 26th?
Right. That's another question. Exactly.
Julius Caesar picked it. He had no reason to pick December 25th.
Right.
He wouldn't have a Christian reason, but does Ron? Do you have a?
Well, I've heard from time to time that the reason that it was January 1st was with their more primitive equipment. That was about when they could tell that the sun was rising a tad earlier.
Could be, although their equipment was pretty good.
Now, I have a question for you,
Julius Caesar.
Sethanne.
Yeah.
Among the Native Americans,
Mm-hmm.
they, generally speaking, they did not write.
Right.
But they did have systems of figuring out the calendar.
Yes.
You know, so they would know when to move south, when to move north, you know, when to buckle down and you know, for the winter, that kind of thing. How did they do that?
Well, actually, there's a famous calendar at Chaco Canyon in New Mexico, and they mark the year with a series of concentric circles going in, spiraling in, and a dagger of sunlight would be on one side of the circle at the equinox, and on the other side of the circle at the other equinox, and in the middle at the solstice. And they could actually time the time of year by watching, it's called a sun dagger, a dagger of sunlight come through rocks onto this spiraling in. They had various ways to do this, but this is the famous one. It's called the sun dagger in Chaco Canyon. It's not open to the public anymore because they don't want anybody destroying the alignment.
How did they get the word to the Native Americans living on the East Coast?
Oh, well, I'm talking about New Mexico. The East Coast Indians had a tougher time, but because they had they had forests. You didn't have as much clear sky, but you had the mound builders, and the mound builders built huge mounds, and they could go up and do sundial type work.
I thought, well, okay.
What an educational session.
Thank you, Sethanne.
You're welcome. You thought what, Ron?
I thought those mounds were burial mounds.
No, they're not. They haven't found bodies in them. They've looked for bodies. Moundville in outside of Tuscaloosa, Alabama, they don't have bodies in the middle. So that if some of them are burial mounds, it could be, but not.
Is there still time for one more question?
Yeah,
Did you go over the Mayan calendar?
I didn't go over it. It's very complicated. It has several cycles embedded within it. It's got a short cycle, a long cycle, and a very long cycle. And the very long cycle is the one that ended in 2012. But all the cycles ended in 2012, and it started over again. It was party time. Just to start the calendar over again. It
So
wasn't.
Are the people that are still using that calendar?
No, but it's a very accurate calendar. It's very good. I didn't go into details because it's very complicated, but it's a very precise calendar. They did a very good job.
Sethanne, what do you think about the calendars that Persians use? Many other countries that used to be part of old Persia still use that calendar. Every season starts with the first of the season is the first of the month of that season. Every season has 3 months, and the first of the month matches the first of the season. Because the calendar that is used here is very confusing. In the middle of the month, you suddenly have a new season.
Yes.
But the other one is so straightforward. I never get confused. Even as a kid, I could remember all the beginnings of every month, every season.
That's right. And many people are suggesting that as a replacement for the Gregorian calendar.
Yes.
Nobody has convinced the world to do it yet.
Yeah. Because first of, for example, first of spring, which is the start of nature, the rebirth of nature, is celebrated as the first of the year all over the world among people that use that Persian calendar. And it's not religious, it's not nationalistic. It all has to be with nature,
Right.
rebirth of nature.
Right.
Yeah, so it's interesting. I don't know why they do not adapt that or adopt it.
I don't know.
I know the answer to that.
You do.
It is. It's that it's very, very, very difficult to get people to change their minds about something that they were born.
Oh, that's
thinking.
true. It's rooted. Yes, it's rooted in everybody's. You're right. In culture, it's rooted deeply.
But the Persians were pretty advanced. They had an advanced calendar system, and Iraq and Iran and the whole Persian Empire was very advanced.
Was it? Yeah.
Okay.
You know, it's sometimes I wonder where did they get, old people in the old ancient time like Mayans, where did they get that knowledge? There are, of course, theories that could have come from other.
They had the capability of doing it. They had observatories. Have you ever seen the observatories in Yucatan?
I've been there actually, Mina, and I went there, God, about 20 years ago.
Yeah, I've never
Beautiful,
seen them,
yes,
but I've seen pictures of them, and they could measure the passage of the sun, the overhead transit, and
Where
by
did they get the knowledge?
where'd they get the what?
The knowledge to
just
build
observe.
all that.
You just observe it for over a couple of years, and you just over time, the same way we do now.
Yeah.
You train your children.
Yeah. And mathematics, I think their mathematics must have been very advanced.
Oh yeah.
Even at that time.
Yeah, but 60 minutes to the hour and 60 seconds to the minute, all that comes from Persia.
Interesting, very interesting, very
Very
educational. Thank you.
you.
You're welcome.